Hello linear algebra student, this video is for chapter 4.6 rank, and this is the third video, part 3. So we're going to use what we learned for rank to analyze systems of equations. So if I know the number of free variables or the number of solutions in a homogeneous systems or non-homogeneous system, what can we conclude? So this can be summarized here. And to recap what we have learned so far in terms of the rank theorem, I want to write down the rank theorem. The rank theorem tells us that rank A plus dimension of null A for a matrix A, which can be a coefficient matrix for AX equal to B or AX equal to 0 is equal to n columns. And what is rank A? In a nutshell, rank A is the dimension of column A. It's also the dimension of row A, because both of them depends on prefix column, the number of prefix column or prefix position. Column A would count the column, row A would count the row position, but it's actually the number of prefix positions. So let's look at how we can use this fact to figure out another systems. A homogeneous system of equation, homogeneous means AX equal to 0. It has 20 equation and 22 unknown. So it is 20 times 22, right? So that means visualize it. You think of it as 20 equations here, but there is a lot of variable x1 to x22. And it's equal to 0. So this is a homogeneous equation. But it has two solutions that are not multiple of each other's. So that means these are not zeros. And that this can only be obtained by having free variables, right? So free variable correspond to dimension of null A is equal to 2, right? To 2 free variables. Whenever you're solving for any equation of AX equal to B or AX equal to 0, the coefficient matrix has free variables, which means that your null A has as dimension 2. Right? So that means rank would equal to what? We use the rank theorem, it would be equal to 22 minus 2 is equal to 20. That means your column A dimension is equal to 20. Now column A is like a column vector of 20 equations, so is a subset or subspace of R20. And if it has dimension 20, this means that column A span the whole R20. All those column vectors in A actually would span them. So can the systems of equation non-homogeneous always has a solution? So if I have AX equal to B, would always have a solution, because no matter what B you have, you can always find an X that would be a linear combination of the 20 column vectors. Have solution. Because it span R20, so any R20 vector that you write, you should be able to span it from column A. So that is the conclusion. So this would be yes. Okay, so then this is the reason. So you will say yes. That's the explanation. The second one is about non-homogeneous systems. So it's AX equal to B, non-homogeneous, 6 equation, 8 unknown. So that means 6 times 8. So you have 6 equation, and then x1 all the way to x8 unknown and equal to B. And these systems also had solution 2 free variable. Now this 2 free variable would also means that your null A, if you change it, that means AX, when you do AX equal to 0, it would always have also two free variable because this B does not interfere with your A in row operations, right? So that means no A dimension is 2. And rank, you do using the rank theorem, rank would equal to what? 8 minus 2, n minus no A is equal to 6. So that means your column A also span R6. And column A is subspace of R6 and it spans R6. So AX equal to B would always have solution. Now if column A is R8 but the dimension is only 6, then it does not, but not in this case. We'll always have solution. So even if you change your B a little bit, you should still be able to find new system. So it is not possible to make the new system inconsistent. Not possible. If you change your B, it's not possible to make it inconsistent. So the answer is no. Not possible to make it inconsistent because column A actually span the whole thing. So that is the second one. Because we introduced rank A, which is the dimension of column A, and if dimension of column A actually, so for n times n matrix, dimension of column A, if it is equal to n, then rank A is n. That means no A is 0. No A is equal to 0. That means column A is Rn. It was form a basis. The column form a basis for Rn. Okay, so these are the conclusion that you can make if you have an invertible matrix. For invertible matrix, the columns form a basis for Rn and it automatically follows that no A is 0. So use this to answer true or false. If B is an echelon form of A, B has 3 non-zero rows. So you know that the first 3 rows, so all non-zero rows are always in the front, right? First 3. This first 3 rows must be the basis for row A, for row A and also row B, for row A and also B. So they will say, so it is not the first 3 rows of A, so it is false. So it is from B. You do not pick it from A because the rows of A may not be independent. We usually don't use that. Okay, the dimension of row space and column space are the same even if A is not square. Yes, this is always the same, right? Because they all depends on prefix column, prefix positions. So even if it's not square, they're actually the same. True. So that's all for 4.6.